Today's Blue is about cloud and Kubernetes. Please welcome the man that made it happen for IBM. Ladies and gentlemen, Chief Technology Officer of the IBM Cloud Platform, Jason McGee.
Good morning. Good morning. Thanks for having me here. Today I want to tell you a little bit of a story, our story. A lot of times at IBM I come to events and talk about our technologies that our customers are using. Today I want to talk about our story as a user of JFrog. And that story is all about scale. Scale from the perspective of the amount of software we are creating, scale from the perspective of the size of teams that we're dealing with, and scale from the perspective of geography and having to deal with deployment of software on a global scale. To do that, I want to set the scene first. And I promise you, I'm not going to trick you into a vendor talk. But I want to give you a little bit of context about what my teams do at IBM, the problems that we're trying to solve, and how we organized ourselves to go do that. So let's start with just the real basics. IBM Cloud. I'm part of the cloud team at IBM. IBM Cloud is a global scale, full stack cloud platform designed for the enterprise. We focus on hybrid as our kind of core architectural foundation, meaning we're delivering the same things across public and private cloud. We focus on multi-cloud and providing tools and management for customers to help them manage applications across different cloud environments. We've built our whole cloud on open source and open technologies, whether that's Kubernetes, serverless, AI frameworks, core networking. We use open technologies as the foundation of that cloud. And we've built it for the enterprise, meaning security and compliance and isolation are really important to us in how we deliver that environment. Now, we do that globally. What does globally mean? Globally means that we're running over 60 locations around the world, spread across all major geographies. That means as software teams, we have to figure out how to deploy and update software across dozens of environments. We're not running, dev, test, production. We have staging environments, we have production environments in data centers all over the world. And so our teams have to figure out how to deal with running and operating. We're running in the public cloud side, of course, services. That means as a software developer, we're not building a packaged application that we give to our customers. We're actually running, deploying and running that software, maintaining it, updating it, incrementing it, fixing it, keeping it compliant at all times. And we do that across a large stack of capabilities, over 100 services that our teams at IBM are building that represent everything from core infrastructure like VMs and bare metal, networking and storage, to platform services like Kubernetes and serverless and Cloud Foundry, DevOps tools like continuous delivery capabilities, databases, analytics, AI, you name it. There's capabilities that we're building in our cloud. And so this is a pretty broad technology space deployed broadly around the world in service of enterprise clients using the cloud. So that's kind of who we are. How do we build all this? And I think anytime you look to build something, the first place I always start is how do you organize people? How do the teams work together? One of the first things we wound up doing years ago when we started our journey to build a public cloud is we changed how our teams were organized. And that was organized around one key idea, which is teams own the life cycle of their service end to end. They own the development of it, the operations of it, testing of it. They run the pager duty so that they get called out at night when things go wrong. They really own that end to end. And we chose to organize in kind of 3 layers. We take that big list of 100 things and we break it up into a set of tribes. A tribe is just a kind of a collection of related services. So there's a tribe around containers. There's a tribe around infrastructure compute. There's a tribe around databases. Within those tribes, there's a collection of services. I have MongoDB as a service or Cloudant as a service, Kubernetes as a service. Those are individual capabilities that we're trying to build. Each tribe might have let's say 5 to 10 services that they're responsible for. Within those services, there's squads of developers that own some subset of that service. Squads are usually kind of 8 to 10-ish in size. They're co-located with each other, so they sit together. The overall service might not be co-located. I have teams that are spread all over the world, but each individual squad that works together on a daily basis sits together. And so if you think about that map I showed you of 100+ services and you break it down like this, you have hundreds of squads, and each of those squads are working independently, updating software independently, pushing to production independently, and they're responsible for the operation of that service. So that was the first thing we did. The second thing we did is said we can't manage this at scale unless we have some common architectural principles that underlie how we build capabilities to deploy in the cloud. And there's many that I could go through, but I think the most fundamental one is we run everything on a common architecture. Specifically, we run everything on Kubernetes. And I heard the stats that were shared in the speaker before me, and that's actually true. I think Kubernetes at 5 years old is still a pretty young thing. There's lots of work ahead of us as an industry on adoption around Kubernetes as a platform, but there are a lot of people who are being really successful running applications at scale on Kubernetes. We run our whole cloud platform that way. I won't bore you with all the details, but if you kind of look at that list of services we're running in Kubernetes, it's a pretty diverse set of workloads: databases, machine learning, API backends, stateful, stateless things, you name it. We've been able to run that on Kubernetes, and that's helped us put some common elements behind how we do DevOps and how we do security and compliance, how we do deployments, because we can get some consistency out of Kubernetes as an abstraction layer across that diverse environment. And then the final way we did this is we thought about, well, how do we deal with velocity? And again, just to give you context, we're doing thousands of deployments a day. It's not that hard to take 100 services times 60-ish locations, 200+ teams. They can each update once a day and you get thousands of deployments. But even individual services have pretty amazing velocity. The graph in the middle there, while probably not very readable for you, is the weekly deployment trend for just our Kubernetes service. And if you could read the data, it would show you that we're doing between 200 and 500 updates a week into that production environment. So pretty high velocity. You have to keep that, of course, up and stable and scalable at all times. We also have to, by the way, track all this stuff. I mean, one of the fun things about running a service is you have to deal with things like compliance, and therefore you have to have proof and evidence of what versions you're running. Did you patch vulnerabilities? When did you patch those vulnerabilities? So the trick is, how do you have that kind of velocity and still maintain visibility into the system? So how do we achieve this? There's a lot of elements that came together, but one key thing for us was artifact management. We needed a consistent way for these hundreds of squads that are working together to be able to manage the software that they're creating and deploying, to have a common place to store it, to deploy from it, to track it, and to leverage that common artifact system as the root of how we do things like compliance and how we drive that scale and velocity. And so we leverage Artifactory to make that happen. So let me spend a few minutes and just talk about how we run Artifactory at scale to support this global team. There were a few things that were, of course, really important to us. We made a decision that we were going to run kind of a central artifact repository, an Artifactory server, as a service that all the other squads could use. We didn't want every development squad to have to figure out how to run an artifact repository for themselves. We wanted some shared ones that could be operated as a service internally between our teams. And that service, of course, had to be highly available. It had to be performant. It had to be up 24/7. We have teams all over the world. There's no downtime. There's no time of the week or day when that doesn't need to be available. If we have security issues and we need to do fast patching, like, the artifact system has to be up. We also needed it to be self-service and automated. If you have hundreds of teams, you can't have the central team running the artifact repository responsible for creating repositories and kind of manually configuring the system. We needed teams to be able to onboard themselves into the artifact repository and be able to deploy and leverage that without having to get anyone involved. And of course, we needed to have a global footprint. We needed it to be available across that map that I showed you. This is to give you a sense of kind of the scale we're currently operating at for Artifactory. We have almost 1,600 teams now within IBM, mostly in the cloud group, but across some of the other teams as well, who are currently using this Artifactory service that we've stood up inside the company. 22,000 producers of content. We have about 6,000 repositories hosting about 55 million artifacts. And we do about 20 terabytes a day of pull from those repositories into the system. So it's running at a pretty reasonable scale to support a really large global team. So how do we build that? This is our kind of core deployment architecture. There's a couple of things that I think kind of interesting. I mean, of course, the Artifactory cluster in the middle is a highly available cluster. It actually runs on a set of bare metal servers. So one of the things that IBM Cloud is particularly good at is offering bare metal compute as a service in the cloud. And so you can see we run on pretty big, large memory multi-core machines with fast SSDs to do caching for that kind of horizontal Artifactory cluster. It's backed currently by a MySQL database that is more vertically scaled. We'll talk about that a little bit later. We use our cloud object storage capability behind that cluster to store all the binaries themselves. So all the actual artifacts live in our cloud-hosted object storage service. The whole thing, of course, runs on our cloud. So we use our own cloud to host these artifacts for our cloud, which, by the way, is hard sometimes, right? Like when you self-host, you get some interesting challenges of, depending on what breaks in your cloud, can you get to the thing you need to go fix it? But we run our whole system on top of our own cloud. And of course, we operate artifact repositories as part of a broader set of DevOps capabilities. We run Jenkins and Travis as a service. We offer Kubernetes Compute as the backend for things. We have integration with some of our own tools like Urban Code Deploy. So we really are trying to offer a full suite of developer capabilities that our teams can leverage in that environment. And we run all of this, the artifact service, our Artifactory instance, with a single squad of 12 people who are responsible for the deployment and operations and maintenance of that environment. So how do we deal with global scale? Today, we basically run 4 instances. We have 2 staging environments and 2 production environments. The production environments sit in Dallas in the US and in London in Europe. Essentially, the way it works for teams is they pick a primary location, Dallas or London. That's the read-write location for their artifacts. And then we do an automatic read-only replica to the other location. So in the event of some kind of outage in that region, we can switch over to the other region, and those artifacts are still available for those teams. But it's kind of one way, and that's something we'll talk about as well, that you have to pick a primary and you get a read-only replica somewhere else. So that's kind of how we stood up Artifactory to service this team. What did we learn along the way? So there's a few things. First, self-service onboarding was really critical for us. To have almost 1,600 teams using Artifactory, we couldn't have that single squad of 12 in the middle of everything. So we built some automation that allows teams to be able to go in, automatically create their own repository in Artifactory. We take that request for that new repository, we run some checks against it, we merge it intelligently into the global configuration that we're using for Artifactory, and we push that change into that global footprint. That empowered teams to be able to consume this on their own. It allows them to automate their deployment. It means it takes 5 minutes or less from the time they want a repository until they have one running globally and accessible to them, which is a heck of a lot faster than it would be if you had to call somebody and get them to do it for you. And so this self-service onboarding has been the thing that allowed us to have that ramp of consumption. We did all of this over the last kind of 18 to 24 months that we were able to deploy the system, put it in place, and get it adopted at the scale that I showed you. The second thing we learned is it was really important for us to have predictable and non-disruptive upgrades of the Artifactory environment itself. Right? I mean, when you build a system like this, it's so core to how everyone's DevOps processes work. You need it to be available online all the time. We needed the latest and greatest Artifactory software all the time. Sometimes we're pushing the boundaries a little bit, so we need to be able to keep current with the environment that we're running. And so we spent a lot of time on automation to help us deploy upgrades to that environment. We kind of run a regular monthly upgrade schedule for the environment, and then, of course, we'll feather in whatever else we need when we have more critical problems in between. And so we have kind of regular currency around the environment that we're running in a fully automated and non-disruptive way, so the development teams don't have to be aware that we're doing any kind of maintenance on the environment that we're running. And then the final thing is to go back to people. And anytime you build a system like this and you build self-service environments, you also have to deal with human behavior, right? People are now consuming this environment, they're consuming it on their own. We use Slack a lot, like I'm sure many of you do. Inside of IBM, we really run our whole system on Slack. I run all of my operations off of Slack. If Slack goes down, everyone should just go home because there's no point, can't do anything. And so for Artifactory, we have a channel where we support our internal users of Artifactory inside the group. There's about 2,200 people who participate in that Slack channel. And they do accidental things. Like one common pattern we saw is people would have a problem. Hey, I'm having this issue. Here's the commands I'm running. They're failing, and they post some command to Slack, and it has something like their API key in it for their repository. And they've now shared their API key with 2,200 people, which is not good, and certainly not good for compliance. And so we wound up having to do things to help manage that behavior. So like one of the things we did is we wrote an automation bot that runs on Slack that watches that channel and looks for API keys and automatically detects, hey, you posted an API key for your repository, and revokes that API key automatically, forcing the development team to go and refresh their keys so that they are now secure again with access to their repository. That's just one example, but I think it's something important to think about when you scale any technology is how are people going to consume it, and what behavior are they going to have based on that consumption that you're going to have to deal with to help them be successful with the environment. So those are some of the things we learned by running this at scale. Let me kind of wrap with a few thoughts about kind of some challenges that we're still working through and some of the things that we want to go do next. So first, challenges. I think the biggest one that we really are working through is the database backend. As I showed you in that architecture picture, we back Artifactory with a MySQL database. It's currently essentially a single instance database. I mean, it's backed up, of course, and we can restore it in the event that it failed, but its HA and scale profile is defined by a single database instance. I don't love that. That's not very cloud. It doesn't allow us to handle scale very gracefully. What we really need is a horizontally scalable HA solution around the database so that that element of the architecture can handle changes in demand and handle failure in a way that's more consistent with the other layers of the architecture. So that's, I think, a really important thing that needs some attention is how do we make that back end more reliable. The second thing that's a little bit of a challenge for us is this idea of interchangeable environments. So, between Dallas and London, these two geographic hubs for the production system, the keys that you use are defined per environment. It makes it hard for teams to switch back and forth, and you can only have a single read-write location for your artifact. So for example, in the event of a failure, if Dallas goes down and that's my read-write location, I can still pull artifacts from London, but I can't update anything because my primary location is down. What we really want is a symmetric system where I can read and write to either location and keep the environment in sync. So true multi-location read-write is the goal we're after so that teams don't have to think about that. And it also will allow us to offer Artifactory as a service. If we wanted to expand that to a third location or scale it globally, that could become transparent to the users because they can touch anything and get those updates. So those are kind of two key challenges that we're working through right now to improve our environment. Finally, what's next? What else are we looking to do? Of course, one of the things we're always focused on is how do we keep ahead of that scale curve? The environment continues to grow, the number of teams continues to grow, the number of artifacts that we're hosting continues to grow. We're doing a bunch of work around monitoring of the system, around applying AI and machine learning to that monitoring, and being able to do a better job of tuning the full stack of that architecture so we can host the scale that we need to support our own teams. The other thing we're looking at is the role that things like JFrog X-Ray would play in that architecture. Today, for compliance, we do things like automatic vulnerability scanning of container images when we put them in our container registry. But we'd really like to push that back further and to do earlier, more comprehensive vulnerability analysis and security analysis of the software that teams are using to catch it as early in the process as possible. For any of you who've had to run, let's say, a SOC 2 environment with continuous compliance, there can be some pretty stringent rules on when a vulnerability is found, how long you have to be able to deploy that fix to your environment. So the earlier we can find problems, the faster it is for us to fix them, and the less time we waste on that clock to keep the environment compliant. And so adding in things like X-Ray into the architecture, giving us that extra level of visibility is a really important next step for us in our use of JFrog within our development environment. So hopefully that gave you some sense of kind of our experiences using this technology. We've been incredibly pleased with the results that we've seen from introducing this into our teams. 2 years ago, every team was doing their own thing. Had their own solutions for where they stored their artifacts and how they deploy globally. We've gotten a heck of a lot more consistency out of the environment and that's enabled us to go faster in IBM Cloud. Thanks a lot.